Hello, welcome to Lesson 5 of our FLL series on the fundamentals of LEGO robotics. In today's lesson, we'll explore two important sensors, the touch sensor and the ultrasonic distance sensor. These sensors help your robot interact with its environment, kind of like giving it eyes and hands. To follow along with this video, you'll need the LEGO Spike Prime, touch sensor and ultrasonic distance sensor, a computer or tablet, and obstacles like walls or small boxes. Let's start by understanding the two sensors we'll be using. The touch sensor, you can think of this as the robot's hand. It can detect when it's being pressed, just like pushing a button. It can even tell how hard the button is being pressed. The ultrasonic sensor, this one works like the robot's eye. It sends out sound waves and uses the echoes to figure out how far away objects are. Both of these sensors help robots make decisions based on what they feel or see in their surroundings. When programming robots, we use units of measurement to tell the robot how far or how long to do something. Some common units are rotations, which are one full spin of the motor, and degrees can be used to represent a partial spin, where 360 degrees is one rotation. Seconds are for time-based movement, and centimeters and inches are for distance-based movement. These units help us give the robot precise instructions for moving and turning. First, we'll explore the touch sensor through an activity. The objective is to program your robot to move forward until it touches a wall or object. When the touch sensor is pressed, the robot should turn around and go back. First, attach the touch sensor to the front of your robot.
Start by opening your LEGO Spike app on a computer or tablet and click on the Spike Prime button. Click on the New Project button, which has this plus symbol. I'm going to title my project Force Sensor Activity, but you can title it how you want. Then select word blocks. Now pause the video and try coding it yourself. You always want to start with the yellow When Program Starts block. This tells the robot to begin running the code as soon as you press the Start button on the screen. Next, drag the pink Set Movement Motors to block and connect it underneath. This tells the robot which motors it should use to drive. I'm selecting C and D for mine because those are the ports that my motors are connected to. If your motors are connected to different ports, make sure to do those. Then add the pink Start Moving Forward block underneath, which just tells the robot to begin driving forward as soon as the program starts. Now drag the orange Forever loop and place it below. This block basically repeats everything inside it over and over again while the program is running. Inside the Forever loop, you'll want to drag an If statement block and place it there. You'll also want to add this blue If the Force Sensors Pressed block and set the letter to the port that your force sensor is connected to. My force sensor is connected to port A, so I'm doing A. This block checks if the force sensor is being pressed, and if it is, the robot will run the code inside the if-then statement. Inside the if-then statement, drag the pink Move Right or Left for Blank Rotations block. You can either make it go right 100 or left -100, which basically tells the robot to turn a full 180 degrees and just turn around. You should set this to one rotation, which tells the robot to just turn for one rotation of the wheel. Under that, drag the pink Move Forward block, which basically tells the robot to drive in the opposite direction after it detects the wall and turns around. I'm setting it to 4 rotations, which just means that the motors will spin for 4 rotations before stopping, but if you want your robot to drive a longer distance, you can set it to more rotations. Now you can test it out. Make sure that your robot is connected to the Spike Prime app.
Next, we can see the ultrasonic sensor in action. This sensor is great for detecting walls or objects from a distance. Your robot will move forward normally, but then if it sees something closer than 10 inches, it will stop and turn to avoid it. Mount the ultrasonic sensor on the front of the robot.
Now, try pausing the video and coding it on your own. Here's how to code it. Just like in the first program, you want to start with the yellow One Program Starts block. Next, drag the pink Set Movement Motors To block and connect it underneath. This tells the robot which motors to use to drive. I'm using C and D again because that's where my motors are plugged into. And then if your motors are in different ports, make sure to update those. Then add the pink Start Moving Forward block underneath that. This tells the robot to begin driving forward as soon as the program starts. Then drag the orange Forever loop and connect it underneath. This block repeats everything inside over and over again as long as the robot's running. Inside the Forever loop, drag an if-then-else statement block. This block tells the robot to make a decision. If it checks a condition and if the condition is true, it runs the then part, and if it's not true, it'll run the else part. Next, drag the blue distance sensor block that says if blank is closer than blank inches, and set it to 10 inches for the unit and set the letter to the port that your distance sensor is connected to. This block checks if there's something less than 10 inches in front of the robot using the distance sensor. If it detects something, the robot will run the then part. Inside the then part, drag the pink move for blank a certain direction for blank rotations and set it to left -100 or right 100 because this will fully turn the robot, and set it for 1 rotation. This tells the robot to turn all the way around and helps it avoid whatever's in front of it. Inside the else part, drag the pink Start Moving Forward block. This tells the robot to keep moving forward like normal if there's nothing in its way. Now, try testing the code.
You've now learned how to use the touch and ultrasonic sensors on your LEGO Spike Prime robot, which are important tools. In the next lesson, we'll learn about gears and how to make your robot faster. Thank you for watching. We hope you enjoyed this lesson and learned something new. If you need any help, feel free to refer back to this video for guidance. See you in the next lesson.